In this video, we are going to discuss how to solve and um, analyze systems of linear equations. In other words, uh, a system of linear equations would be scenarios where we have more than one linear equation at a time. So in this graph right here, we have two different linear equations. We have y equals f of x and y equals g of x. Now we don't know the equations for f of x and g of x, but we do know one important fact, which is that they intercept at the point -4, 6. Just from this graph and by knowing the point of intersection, we can answer two questions. Number one, we can solve the equation, when is f of x equal to g of x? And we can solve the inequality, when is f of x larger than g of x? All right, let's start with the first one, which is when is f of x equal to g of x? Notice that since -4, 6 is a point on f of x, that means that -4, 6 is a point on the graph of f of x. So that means f of -4 is equal to 6. So when x equals -4, f of x is equal to 6. It is also a point on the graph of g of x. So when I plug in -4 into g of x, it will also be equal to 6. So when is f of x equal to g of x? When are the outputs the same for both of these functions? Well, the f of -4 is equal to 6 and g of -4 is equal to 6. So their outputs are the same when the inputs, or the x value, is equal to -4. So A, f of x equals g of x when x is equal to -4. Right? Because when I plug in -4 into both functions, my output of both functions are the same. So they have equal values for that. They have equal outputs for the input x equals -4. All right, when is f of x larger than g of x? So let's look at g of x. G of x is right here. And all the points, all the y values that are bigger than g of x are basically all of these points above this line. Okay? Hopefully that makes some sense. So I could kind of shade that in using my highlighter just to get an idea. So if we look at f of x now, f of x is this line right here. So when is it bigger than g of x? Well, it would be in this section, starting at the point of intersection, going to the left, right? So how do we express this, right? When is f of x greater than g of x? Well, think about for what x values is f of x greater than g of x? Well, my x value right here is -4, right? And so all the x values of these other points, like this point right here, here are the x values. they're all to the left of that point, x equals -4. So when is f of x bigger than g of x? All these points going to the left, right? So those are all the points less than -4. F of x is greater than g of x when x is less than -4. Now notice we didn't put an equal sign there. The reason why is, if we look at this, when x is equal to -4, that's when f of x is equal to g of x. It's not bigger than g of x. So we don't want to include -4, but any point to the left, any x value to the left of it, results in a y value or an output that is greater than g of x. All right, so there is our solution to this problem. Next, let's solve systems of linear equations. So we have two equations, f of x plus equals 3x plus 5, and g of x equals -2x plus 15. So let's first solve f of x equals 0. I'm going to write down this formula, and then I know what f of x is equal to. F of x is equal to 3x plus 5, so I'm going to replace f of x with 3x plus 5 equals 0. Or another way you could think about it would be I could start with f of x equals 3x plus 5, and we could say when is f of x equal to 0? Well, I'm going to replace f of x with 0, and I get basically the same equation. So I'm going to solve for x. First, I subtract 5. These cancel out. I get -5 equals 3x, and I'm going to divide by 3. -5 is not evenly divisible by 3. 3 does not divide -5 evenly. And so I have a fraction -5 over 3, which is not simplifiable, which I cannot simplify. So this will just be, my answer is x equals -5 over 3. So when the input for f of x is -5 over 3, the output is 0. Part B, when is f of x less than 0? Again, here it might actually it might be helpful to start with just this. F of x is less than 0, and again, replace f of x with what it's equal to, which is we want 3x plus 5 to be less than 0. And we're going to solve. Now we're going to solve it almost exactly the same way as we did the other problem. Divide by 3. And remember, whenever you multiply or divide when solving an inequality, always think, am I multiplying or dividing by a negative number? In this case, I am not. It's a positive number, so I don't need to switch the order of my sign. And so when is f of x less than 0? It'll be when x is less than -5 over 3. All right, let's look at part C. When is f of x equal to g of x? Well, f of x we already have highlighted. F of x is equal to 3x plus 5, and g of x is equal to -2x plus 15. So I'm going to replace f of x with what it's equal to, and I'm going to replace g of x with what it's equal to. And now I have an equation, and I'm going to solve that equation. I'm going to get rid of this 2x. So we have a variable term and a number term on both sides. So I always like to get rid of the smaller variable term in this scenario. So I'm going to get rid of -2x by adding 2x to both sides. It's not the only way to do this, but that's the way I prefer. 3x plus 2x is equal to 5x plus 5 equals 15. Next, I subtract 5. These cancel out. I'm left with 5x equals 10, so I divide both sides by 5. So x is equal to 10 divided by 5 is 2. And we can quickly in our mind just double check, does this, or let's just do this. Let's double check that this is true. F of 2 is equal to 3 times 2 plus 5. And again, I'm just using this equation, which is 6 plus 5, which is 11. G of 2 is equal to negative 2 times 2 plus 15, which is negative 4 plus 15, which is 11. That checks out. So that is when they are equal. All right, next we are going to solve f of x when is it greater than or equal to g of x. And again, I'm just going to plug in for f of x on the left, g of x on the right. And this is basically going to be nearly identical solution. So I'm going to do this rather quickly. Add 2x to both sides. Subtract 5 from both sides. And divide by 5. And I get x is greater than or equal to 2. And that was actually part D. So that is my solution. F of x is greater than or equal to g of x when x is greater than or equal to 2. So now we're going to graph these functions. I'm going to do it off to the side here. First function is f of x equals 3x plus 5. So my y-intercept is positive 5. 1, 2, 3, 4, 5. I'm going to put a dot. And my slope is positive 3. So that means I'm going to put that as a fraction, 3 over 1. That means I go up 3 and to the right 1 to find the next point. So I'm going to go up 3, which would be something like this. 1, 2, 3, and over 1, I get my next point. I can also go down and to the left. 1, 2, 3, 1, and I get my next point. I can do that again. 1, 2, 3, over 1, and I get my next point. And I can keep doing this to get a few more points. Down 3 over 1, and I think that's enough for now. I notice that I mistakenly got rid of my x-axis. I think it was probably here. Let me make sure that's right. That is correct. Okay. The other one is going to be a little bit higher, so I have to go up to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. In fact, I think, no, that'll be fine. All right. So my y-intercept in g of x is positive 15, which is right here. And my slope, in this case, is negative 2, which means I go down 2 and to the right 1. So I'm going to go down 2 and to the right 1, and I'm just going to keep on doing that. Down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, and I think that's enough that I can make a decent graph. Now, one thing you might notice is that my graphs didn't intercept, so I need to add some more points to for the graph of f of x. So I'm going to go up, starting at this point, I'm going to go up 3 and over 1, and there, notice we are at this point right here, which is the point of intersection. And I can do that a couple more times, and now we are good. All right. So, what is this point? Well, if we follow this down, this is my x value is 2. And my y value, if I count, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And so that is my point of intersection. That is when f of x equals g of x. And so I labeled it. And that should make sense because we found out that when x is equal to 2, my outputs are the same. And notice we noticed that my outputs were equal to 11 in both situations. We can check some of the other things that are true. Let's check A and B. So f of x should be equal to 0 when x is negative 5 over 3. And so negative 5 over 3 is about 1.6, so almost 2. That's basically what we have. It's not the most beautiful graph that I've ever graphed. In fact, I would say this point should be here. And so maybe if I graphed it a little bit better, you would see that hits about at negative, and negative 5 divided by 3 is about negative 1 2/3. So that looks about right. When is f of x less than 0? That would be in this part here on my graph. And those are all the x values to the left of negative 5/3, which would be this point right. That's the x value right there. And so that makes sense. Yes, f of x is less than 0 when x is less than negative 5 divided by 3. And then finally, when is f of x bigger than g of x? Well, that would be here. That's the only place where f of x is greater than g of x. That's the only place where the red line is above the blue line. And so those are all the points where x is bigger than 2, where the x values are greater than 2. And yes, that's right. All the points all the x values to the right of that point of intersection. Okay? And so that is a few examples. And so we've learned a little bit about how to solve and analyze systems of linear equations. I hope this video was helpful, and we will see you in the next video.